Thanks, man. My name is Adam Schellenbarg. I was the gameplay lead here at Segway Militia. Behind me you can see a few of the things that I worked on, but today I'm going to talk to you about the Bezier Curve system. So what exactly are Bezier Curves? It's an algorithm originally derived by Paul de Cassavant. The algorithm that we use was later derived by Paul Bezier, or Pierre Bezier, excuse me. We use a 6-point version of this, and essentially what it does is it makes a smooth curve out of a set number of points. In our version, we actually use 6 points. Some sample applications that you can see up here are pen tools, such as in Photoshop and Paint.net, modeling programs to make smooth surfaces, and even font programs that make the curves of the individual letters. So accomplishing Bezier, what we did is we actually made a test application just from one of our old labs. We made an object in the world and moved that object along a Bezier curve and the camera along a separate Bezier curve, just to make sure that we got the movement that we wanted and that it would work properly in our game. From there, we actually went through multiple iterations. We started off with a single Bezier curve that basically went through our entire level and controlled the player's movement. However, this did cause some problems with our collision, so we switched to a multiple Bezier curve, which actually, we use it on the QuickTime events and for our transitions themselves. But other than that, the player has free roam when they're off these sequences. So Bezier in our game, why we actually use it is the smooth movement that I talked about earlier, but also to give it a cinematic feel. As we can move the camera and the player separately, we can pull off some really interesting shots with these. As you can see here in the sample behind me, this is a sample jump in our game. So what we do in the modeling program is we actually insert the curve into the into our level. As you can see, this curve is actually made up of 6 points. And then from there, we put the player onto this curve and we update the player along the curve to give her that smooth movement. Well, another system that uses the Bezier Curve system is the actual menu system. And to talk to you more about that, I'm going to bring up Adam Schlesinger.
Thank you, Adam. I'm Adam Schlesinger. I'm the design lead for Segway Militia. You can see a few of the things I've worked on behind me here, but today I'm going to talk to you about menus. As you can see, our menus are rendered on 3D billboards, which we place throughout our level within the game. So beyond the initial load up of our game, you're instantly set within the game world. It instantly immerses the player. As you can see, as I click through the menu options here, that it works as you would expect a menu should. We can do this because we have a strong modular code base which allows us to easily place new options and new menus within our game. So where does the Bezier Curve system come in, you might ask? Well, here we have our game world, and now you can see that the billboards where our menus are highlighted. So if we want to go from, say, what will become the main menu here to the difficulty menu here, that we need to create a Bezier curve going from one to the other, which we move our camera along. These transitions are short. They allow the player to see the world before they hop into the game, and they're easily skippable if the player wants to go from menu to menu. So why our menu system? Well, one, beyond the initial load up of the game, we have no loading times within the game, which is great for any game. We have a very unique menu style, and it allows the game player to preview the game world immediately, draws them in. Speaking of the game world, one of the people responsible for that is Chris Venezia, who I'd like to bring up now.
Thank you, Adam. I'm Chris Venezia. I was the tech lead here at Segway Militia. Behind me are some of the things that I worked on during the project. But today I'd like to talk to you about spatial partitioning. So what is spatial partitioning? Well, spatial partitioning is a way to break up a large world into smaller, more manageable chunks, what we like to call bite-sized chunks, similar to the way that you would eat an elephant, which is bite by bite. So accomplishing spatial partitioning. Here's a screenshot of our game world. So the first step is to insert volumes to form what will eventually become the track segment. So here you can see the lines in red represent the left, right, top and bottom bounds of the track segment. The lines in blue represent the collision volumes. These will stop the player or impede their movement. The lines in yellow represent triggers. These are the starts of QuickTime events and scripted sequences. So as you can see here, the area highlighted in green is the playable game area, and the area highlighted in red is the places where the player cannot go, basically scenery of our level. So from here, we save it into a file format that is recognizable by the game, and when the game is started up, this level is loaded up and ready to go. So why partition? Behind me you can see the segment we just created in red. You can already begin to see that it's pretty small compared to the cityscape. And here again, That's the same segment in red. It's quite small compared to the overall vast layout of our city. So you may ask, why do we partition? Well, to make the game possible to run smoothly, we partition for speed during collision checking. We only run collision checkings in the highlighted segment where the player is. So getting all this into the game poses a significant problem, and I'd like to bring up Matt Schellenbarg again to talk about what problems we encounter.
Hello again. The first thing we'd like to talk about, or problem that we overcame, is animations. From the beginning, we've had issues with our animations, getting the player to look correctly, not have squiggly arms, and just horrible things that were happening. But eventually we overcame the problem, got her animating correctly, and doing the tricks we wanted to when we wanted her to. And then another problem was the large level design that you saw when Chris was presenting. The level itself presented such a huge problem that one of our teammates was pretty much for 3 months stuck making and modifying our level and making sure everything was laid out correctly, because at the beginning our level design was not adequate for what we wanted to do. And another issue that came along with level design was collision. And because we wanted to keep up the fast pace of our game and we wanted the player not to slow down, we couldn't just stop the player on the board. We had to find a clever way to slow them down a little bit but not completely destroy the speed of the game. And we feel that we came up with a good solution for that. And to talk to you a little bit of how we overcame these problems and what we learned in the process, I'm going to bring up Brandon Hilton.
Hello again, everybody. I'm still Brandon Hilton. To talk about what we learned, the first one is focus on the gameplay. For the first couple of milestones, we had some problems with this where we were trying to introduce some new tech that we had never worked with before, and because of it, we had spent a lot of time focusing on that. And it was hard to get the feel of the game across the people that first started playing it. So heads up to anybody going into Final Project, definitely focus on the gameplay right from the start and make sure you get that in there. The next one is test code and spike solutions. Spike solutions are test applications that are separate from the code project that you're working in. You want to do this because you can set up and test and make sure everything is working outside of a different application and then integrate it in. We had a couple instances where we had just tried to integrate code right from the beginning, and because of this we ran into a couple problems. So save yourself the time, start with test solutions, and it'll be better off. Also, asset dependency. Asset dependency is the worst thing you can do. Besides our level, one of the things that we were planning on doing in the game was having a tentacle creature. The tentacle creature was what the prism mates were supposed to turn into, and unfortunately, just due to time constraints, we couldn't get them in because we just didn't have time to get the text set up for them, and then we didn't get the asset. And along that note, features will be cut from any game. Be aware of this when you go into the final project, that whatever you have in mind, something's going to get cut out of it, and just be ready for that time and accept that and keep moving on and keep trucking. But enough of this, it's game time. So.